Okay, so as you can see, the mighty M1b is back in the shop here. And reason being is the end of last summer, beginning fall, I can't remember, I went to Jason Zogage Train's house and brought this along. And it was running on his layout, his nice layout he's working on right now. And this thing was just cruising along on his layout all night and then just decided to blow itself up. So it was a pretty good meltdown. I lost the sensor, the tack sensor. I lost the EOB motherboard, and I even think I smoked the R2LC from what I remember. And as you know, I don't really like to run smoke, especially in my brass engines. But I guess if I'm going to run smoke, I'd like it to come out the stack and not out, from underneath the firebox and from the tender and all that stuff. So what you're looking at here is a quickie electric railroad job I did on it. This was an electric railroad cruise commander board I had kicking around. And this is kind of the one, I only see these, I think, in the OEM setups where it doesn't actually have the screw terminals like these guys. It had a header, so I just took the header off and made some solder connections through the through holes there. So it was a quickie electric railroad and 3-board Rail Sounds 4 setup job I did on it. So what I'm going to do is clean it up. I'm in the process right now of 3D printing one of my Rail Sounds 4 standoff boards with the, and I'll have those brass strips I like to do underneath for the power terminations. So it's kind of like a combination standoff and terminal strip, I guess, distribution strip. So it'll clean up all this wiring. And I have 2 magnets on one of these tender wheels, so it's giving me a floated and incorrect chuff. I think I'm at like 4.38 chuffs per rev or something. So I'm going to go into the engine and set up proper magnets on one of the drivers. So shouldn't be too involved, but we'll see what happens. So I'll have to rewire a few things and we'll get to it. Okay, so I'm going to get the boiler shell separated from the frame, and I just want to show you, sometimes on these third rails you got to look out for little surprises like this. There is a reach rod from the power reverse to the bell crank, and it's this little guy here, and it was just pinned through with a thin piece of brass wire. And on some engines, when you go to pull the boiler off and it feels like something's still holding it down, it's always worth going through and making sure you got everything disconnected. So other than that, it's pretty straightforward. 2 screws under the apron and 1 up through the cylinders there. So here's a quick look at my kind of quickie mount I fabricated for the Rail Sounds setup. This is just before I think I got my 3D printer, at least a couple months before, so this probably would have been the last of the scrap box fabrications I did for one of my engine projects. So you can see I repurposed one of the L brackets in the tender and came up with this. You can see there's a couple standoffs in there. Just holds the motherboard down. So this is, you've probably seen this before, but this is my little 3D printed solution. And I could play around with the length of it and the height of these standoffs for clearance. But the other feature I have on here is provisions to mount these 2 brass strips, which will become my kind of terminal strip. So, and that'll go right in the center there. Just gonna drill this, tap this out for 2.5 millimeter hardware. So you can see I'm a big fan of these like laptop repair kits you can get off of Amazon, because they have all this common smaller size metric hardware that the importers like to use on these trains. So I've been using them on all my little projects too. So that's the basic concept there. Okay, so here's the tender going back together. Like I said, here's my modern standard for mounting these Rail Sounds 4 boards. And I'm gonna get ready to just tuck these wires in and reconnect the shell and get the tender back together. And then we'll get into the engine some more. Just a couple thoughts about how I want to set up the chuff on this guy here. I want a proper crank pin synced chuff. So a couple options. I could just do the old magnet on the inside of a blind driver. There's plenty of clearance for these guys. I think these are 1 millimeter thick. Even with the lateral slop available, I could pick it up with my reed switch, no problem. But I'm kind of thinking, I've been wanting to try my little invention here, my little magnet retainer that would go around an axle, and I think I found a good spot for it. It would be on this axle. I'm gonna have to take this plate off and then mill out just a slot here. This is about 12 millimeters in diameter total. It's gonna go around the axle. This is a new print, just adjusted for a 5 millimeter axle. So these will get glued to the axle, and then I can place my reed switch to pick up these overturning magnets. So let's see what it'll take to use this. I would love to use this. I have not found an engine to do this with yet. I don't know if you remember, on the Q2 projects, I did use one of these on the tender axle, but I only populated it with one magnet on each side. But I'd love to use this in an engine. That was the intent when I first came up with this little doodle. So let's see. Well, it actually turned out these are 6 millimeter axles. So I'm going to have to modify this guy one more time. All right. That should be correct. Okay, so here's the basic concept now with the frame here milled out. I can expose my magnet retainer, and you can see my reed switch is in a rough position to where it'll pick up these magnets going by. And like I've shown before, these couple magnetically the most efficiently in this kind of axial direction. So I'll make a little 3D printed mount for this guy, kind of like I did before on that, I can't remember what engine it was now, the Q1 maybe, so that I can adjust this for most efficient pickup. And then I'll be able to also kind of phase this retainer here to get me proper sync with a crank pin. So it should be kind of fun. Looks like I gave myself enough room for the lateral play here. So here's the reed switch retainer now. Just a quick, simple print. And it's adjustable, so I can kind of adjust it fore and aft. And then I just played with the angle to kind of get it close to the center. You don't have to be super precise with these guys, but I did want to be able to sync the magnet with a crank pin position so I get proper chuff. And I think I'm pretty close. I'm hooked up now to my meter just to test it out. So we'll see. I can actually delay that a little bit. By moving the reed switch back. That looks closer. Oh, that's annoying. Anyway, that's the idea. As that magnet tickles that reed switch, we get a chuff. Pretty cool. Alright, so there's the magnetic chuff cam living in its new home, and seems to be working quite well. See, I have the chuffs triggered at the dead centers, just what I like. It seems very responsive and reliable at all speeds. I repurposed some of the original sensor wiring to bring the chuff closure signal back to the electric railroad board. So all that's really left is to put this back together. I'll show you what it looks like from underneath first, though. So here's my reed switch holder. If I was to do this again, I'd probably be inclined to make the cam a little narrower and then maybe offset it to one side or the other if I have a center mount like this. I was just trying to take advantage of this screw hole here. So I kind of angled the reed switch holster here just to line up with the magnets, but it's actually pretty forgiving. And by sort of shifting the chuff cam during assembly, I just gooped it on, and then I was able to kind of just bully it around a little bit till I got the phasing pretty close. And I could also get a fine adjust on the crank pin phase by moving the reed switch in and out of this holder here. But that's what it'll look like from underneath. So I just happen to have some gray PLA in the printer, otherwise I would have done it in black. So maybe I'll just put a little paint on there later. But I'm gonna get this back together and take it for a spin. All right, so my recently refurbished M1b is back on the layout. It's electric railroaded, and I've I've got some new sounds in it too. I'm not sure if I mentioned that during the course of this little video. I have the old Lionel K4.5, I think 5385. That was the second alternate number that you never saw very much. Really good sound, so you'll hear that here in a minute. But right now, I just wanted to show you with Electric Railroad in here in cruise mode with the sound off. It is a very smooth runner. I forgot what the gear ratio was on this guy, but it's like 23, 24 to 1. Real smooth. Now this is pulling a pretty heavy train too, so I like it. No switching noise either compared to the old EOB. Like I said, I used to keep the EOB stuff alive just because I could, and with the idea that if it did blow its guts out, you know, for any reason, I would just change it out for Electric Railroad. So that being said, when you do that, you got to come up with a way of triggering the chuff, so that gives you the opportunity of getting a nice crank pin generated chuff, which I really like. And then you have to come up with a way of doing your own sounds, especially if you're like me. I like the old Rail Sounds 4 setup. So anyway, let's turn the sound on and give this thing a nice run. I like that whistle. As you can hear off in the distance, that 4 chuffs being triggered off my little magnet machine there is pretty reliable at any speed. Here it's speeding up, going off into the distance, and it's not dropping any chuffs or anything, so I do like that whistle. That's a nice Weaver N5C. That is a cool caboose.